Okay, so you're quickly becoming an atomic absorption expert. So congratulations on making it this far, maybe without falling asleep, because we know how these videos can get if you watch many of them back to back to back. But no one said that you had to watch them all in a row, did they? So break them apart, pretend like you're in lecture, pretend like you're sitting in class for an hour, watch a couple at a time, go take a break, and then come back and see me. So in the previous video, I alluded to the fact that this one was going to talk about the monochromator. Now we need to talk about the specialties of the monochromator. If you are a student in our program, you will actually see that the monochromator that we're talking about right now is the same exact monochromator that we have talked about before with the other spectrophotometer instruments that we have used in the classroom and that we've presented in the laboratory. But if you're a new student or you're prepping for the competition that we're sponsoring this year, then you're probably a little apprehensive about the monochromator. Maybe you don't really know what it does. Maybe you don't know the purpose. Well, guess what, folks? I'm here to tell you what it does. So let's first break down the name monochromator. Hey, and for you people that are in our classroom, this is a good review. Maybe you didn't catch it or understand it the first time. Well, you're going to understand it now. So, monochromator, mono means one, right? I'm numero uno, number one. So, a monochromator's job is to pick one. Now, pick one what? Well, the word chroma, C-R-O-M-A, that word chroma translates to color. So monochromator picks one color. Well, that doesn't make any sense. Well, yeah, it kind of does in atomic absorption because we said that atomic absorption focuses on Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. And this area spans about 400 to 8 to 900, give or take a little bit. And this area that includes Roy G. Biv, well, different metals will absorb different wavelengths, and different metals will emit different wavelengths, depending on whether you're looking at absorption or emission. Well, they're not emitting and they're not absorbing spans or big windows of nanometer. All of the metals, like we've said before in the past, are very specific to one wavelength. Now, some of them can have multiples, some of them can just have one or two, but we're talking about one number in particular that they respond to the best. And maybe there's another number that they respond to not as good, but maybe just as good. And if that's the case, then we're going to have to find a piece of the instrument that allows me to hone in on one number. And that's the purpose of the monochromator. All right, so let's draw the monochromator box or the piece. Typically what you'll find in a schematic is a monochromator is a black box and there's a entry and there's an out. Okay, so light goes in and light comes out. The problem though is what happens to the light inside of the box. Well, inside, typically you'll find a couple of mirrors, and I'm going to draw one here and I'm going to draw one there. And the light beam will come in and it will hit one of these mirrors that will then reflect it onto a very special piece that we'll talk about in just a second. And that piece will then do something to the light. And then it will reflect what it does to it to another mirror that then delivers it outside of the monochromator box. So the monochromator's job is to pick one wavelength at a time, one color in a way, and light goes into the monochromator Something happens to the light on the inside, and this one wavelength or one particular color leaves the monochromator and it goes into the detector eventually. Now, what is this kind of dashed piece that I have just labeled here? Well, this is called a grating. And a grating is very similar to a prism. So if you've ever seen a prism and you shine sunlight into the prism will take that light and it divides it up into its individual components that you can see with your eye. This is how rainbows happen in the sky, right? So red, orange, yellow, green, blue, indigo, violet. Okay, so what happens is that the light hits the grating and then the grating will separate the light into red, orange, yellow, green, blue, indigo, and violet. That's its job. We don't call it a prism, though. We call it a grating. And the grating is basically a piece of glass. And on this glass are very fine lines that are etched into the glass. Now, the number of lines will basically tell me the resolution of the monochromator. Now, what does that mean, right? Well, let's say that I have a certain number of lines, and let's say that this number of lines that I have is able to divide the light up into the individual wavelengths for whole number. So, for instance, 500, 501, 502, 503, you get the drift. That's the monochromator. That's its job. It takes the light that it's being given and it divides the light up into the individual wavelengths. And this is what we mean by that. And it begins to scan every single one of those wavelengths that it needs to for the analysis. Now, if I have more etched lines, I increase the resolution. So, what does that mean? Well, if I spend a little bit of money and I go in and I increase the number of lines that are etched into the monochromator, well, all of a sudden, I'm just going to put extra lines here. All of a sudden, maybe I can do a better job of dividing the light up into the individual components. So maybe this time I can do 500.1 and then 500.2 and 500.3 and 500.4, and I can divide the lines or the wavelengths up into smaller and smaller pieces because of that. This allows me to really focus in on one specific wavelength that I want. Instead of 512, maybe 512.4. Now, granted, most of the time in an AA instrument, whole numbers are going to be okay. This is not going to cause us a problem. We don't really need to go all the way down to the point where we're looking at fractions of a nanometer. Maybe in UV vis, but not in atomic absorption. So that's the purpose of the monochromator. It takes the light from the bulb and it divides the light up into the specific parts. Now, you're probably scratching your head for a minute and you're saying, well, wait a minute. I thought that the bulb gives off the wavelength that's specific to the metals that I'm trying to analyze for. And the answer is yes, it does. So, for instance, if I have a copper bulb, that bulb is typically going to give me one wavelength that we call the primary wavelength, and that goes into the sample, which then makes it to the detector. However, in between that, we get a monochromator. And I know that the bulb typically does a very good job providing a specific wavelength that needs to be measured. But just in case it needs to be cleaned up, just in case there's interferences, because you've got to remember this thing is kind of outside, there's extra light that might be given to the sample or to the monochromator that might reach the detector, and you want to filter out all of that. You want to get rid of all of those interferences that you can. So the monochromator just makes sure that that light is indeed the specific wavelength that you have told it to measure. That's the thing with the monochromator in the AA. Okay? All right, so that's the monochromator. The grading will determine how good can you go, and it delivers the specific wavelength to the detector. Okay, so in the next video, that's it with the monochromator, folks. That's all that the monochromator does. I told you it wasn't very exciting. At the same time, it's not very complicated either. So in the next video, we'll make it onto the detector, and we'll talk about what the detector does and how it does its job. And yet again, you're going to see the same type of detector here as what you saw in our previous instruments. So if you're a student, you've got a review. If you're someone from the outside of the program watching the videos, well, maybe you need to watch the video on the detector and how it does its job. All right, so we're almost done with the lecture portion of the AA. So almost there. I can see light at the end of the tunnel, but we'll still not be done with AA because we'll have to talk a little bit about some of the weird, kind of strange things that might happen, or maybe some of the advanced learning concepts with AA that we should be exposed to. So that's what we'll do in the next video. We'll talk about the detector and we'll move on from there.